Hello, everyone. Welcome to your weekly webinar number 17 with me, Michael Floyd. I am your mentor and your mentee. You learn as much from me as I learn from you. Now, the first thing that you should learn from me is never to cut your sideburns like that. But now, back to the serious message. Fill out the introduction form. Number 5 out of 12 of you, you still have not completed this introduction form. Okay. The last 1-2 weeks that we have to this program, let's finish it up strong. Let's try to get the data Udacity needs in order to help its future students, and let's try to complete these projects. I know 7 out of 12 have not completed the second project. Let's hopefully more people get that done. And congrats on Udacity needs in order to help its future students. And let's try to complete these projects. I know. Hold on 1 second. I am not sure why I am repeating myself. 7 out of 12 have not completed the second project. Let's hopefully more people get that done. Okay. I hope I don't have this repeating the Hangouts on air. Seems to be messing up a little bit. And congrats on Udacity needs. To help its future students. And let's try to complete these projects. I know. Okay, I fixed the problem. Apparently, I had the same video running in the background on a different tab. That should be fixed now. So, like I was saying, let me get back to my notes. So, congratulations on Wenji for completing the third project. Fantastic. So, Sine is on the third project right now. I hope he gets it finished. And like I said, every time the money's already spent, if you're not on the third project, 30 minutes a week or a day is probably not beneficial. I would say probably spend all of your time trying to complete this, right? We want to make sure our money and time are best kept up. So in the case of the time spent for the 3 students, we have student A that lives at his home with his parents, no children, no job, and student A would have completed this with ease. And we have student B and C who all have responsibilities, but student B inconveniences everybody else, whereas student C still keeps up with everybody else and makes everybody else happy. So let's be completely like student B and let's get these things done. So this week, this webinar is going to be on database design. So if you're choosing a relational database, and the great thing about the relational database as opposed to non-relational is you can make these designs, you can make these relations such that it will cater to your needs and reduce the amount of redundant information, and also accessing and querying and deleting and other things you can do to the information. These things can be done in a very, very quick manner and an organized manner, which is why the design of the database is very important to keep all this organization there and relay all the necessary information which you need and your users need and your clients need. So there's a couple of things: no necessary redundant information, no creation of tables that aren't necessary, right? So tables need organization, must fit overall scheme of the purpose. So the purpose of why you're doing the database in the first place will help you as far as insight as to how to draw the database. And using the best relationships possible. Set the correct primary keys, foreign keys, And we're going to see, I just go over the notes. What I could do is start sharing my screen and get this underway. Okay, so my screen is shared. All right. So this is a great article I found that actually also a good thing is it has a chart which we can use that we're going to be using later. But if you never did database design and you want to learn, this is a great way to initially understand with some basic principles to help you get started. So a well-structured database, like it says, is safe space, maintains accuracy, and provides easy access in many useful ways, right? And so it breaks it down into 4 different components. Identifying what the purpose is, organizing the tables, and developing the relationships, and then normalizing the tables, which is just normalizing is rules that are made whenever you are creating tables. So for the requirements, identifying the purpose of your database. It's very important to understand the purpose, because the people and the clients who will use the database need to be able to easily access the information. So the people who will be using it the most, you should understand what their use for it is and what the purpose of the information will be for them, right? And if they're analyzing what you're getting or receiving as data, as far as the timesheet survey and combing through, other data systems that's already there that you're piggybacking off those systems. All these things are important when you are initially creating a database, right? So you gather all the information that you can possibly get, right? So, for example, we have customers and products here, and we have orders here. So we need to know all this information in order to be able to structure the table the way we want. And database structure, the building blocks of a database. So, now we have to structure this in a good format, right? So, all of the information in the SQL table will be from data types such as these. These are not all the data types. These are definitely the most common data types. And you could also specify the length of the data types, whether it should not exceed a certain length or it should be at least a certain length. You could do that as well, and all this, as far as telling, the exact length of how long or short the data should be, that will help you as far as conserving memory whenever it is possible. And talk about auto number, which for each row will generate a unique number, which kind of like will be a primary key. So primary keys are very essential in databases, because you will want a lot of times unique rows, and those unique rows must consist of a key could make a row unique, and a key doesn't be just one column. It could be the additive of many columns, such as if you have a user and you have an order, right? A user can have multiple orders, so you can have the user ID plus the order ID is the primary key. And so now we go on to relationships between entities. And this covers one-to-one, one-to-many, and many-to-many. Now, one-to-one is, so for every instance of every row of A, there could only be one of B. they give an example here where you have a country and you have a UN representative. So, for every country, there's only one UN representative. Now, why would this be helpful in any way? Why wouldn't it just be all in one table? Well, it is okay to put it in one table, but at times, perhaps the country might not have a UN representative. And if many of your uh, rows do not have a UN representative, then in that table, which you have the country and UN representative information together, that table will then have a whole bunch of empty slots within the rows that do not have the UN representative. And so, that is, I mean, for, countries and UN representatives, it's like 300, 400 countries and UN representatives. I don't think there's even that many countries, but I mean, yeah, I mean, so it's not a lot, but, this was getting larger. Like, let's say let's say if you're doing a database for for a large amount of people, like let's say a Facebook or whatnot, and you had columns like first name, middle name, last name. Although people may have first and last names almost all the time, middle names are generally sometimes there, sometimes not there. So you could have a one-on-one different table that has all the middle names, right? Referencing, of course, the users, the first referencing, of course, the actual table with the first names. So now you have a table that only has places in the table where the users have middle names. So the difference would be right here. You would have, let's say, if you have 50 million users and 25 million have middle names, then you have 25 million slots. If both tables are combined, you would have 25 million slots that are empty. Whereas if you had two tables, then all you have is 25 million rows here, and you have the 50 million here and nothing empty. So that is one advantage of doing one-on-one relationships. And you have one-to-many relationships, such as a political party can have many presidential candidates, right? Or a better example, if you have a online store such as eBay, you can have user and you can have orders, right? So one user can have multiple orders, and that's how we specify this is a one-to-one. So one user can have multiple orders. So one political party can have multiple presidential candidates. As we see here, we have one country can have one representative, and these are the ways we represent in the structure. And you can have many to many. They actually do give a good example for many to many in this students and classes, right? Since a student can take many classes, right? And all classes, of course, have multiple students. This is a many to many relationship, and you can't just directly enforce a many to many relationship given how the tables are structured. What you want to do is you want to put a table in the middle of that relationship, and you would have student, and you would have one to many from the middle table, and you would have one to many going to the middle table. So both are have many relationships toward the middle table, but you always have a table in the middle. And they give a great example here. You have enrollments. It's what they call the middle table. You have student ID, course ID, and you have date, right? So, the student can be in many courses at the same date. Let's say they use date. Let's say they do it like fall or spring of 2019, right? The date can be fall 19 or spring 20, right? So if your date is fall 19, then your student will have many courses. And of course, many course IDs uh, will have uh, many different students as well. So that is how you get to do a many-to-many relationship. And this is just other things you can do in SQL, such that making a field mandatory or not for another field to be there. If you see here, right, if there's no country, then you cannot have a UN representative. They just give you an example of the things or the restrictions you can impose when you are setting up your relations. And recursive relationships, right? So within, let's say, a user table or within a employee table, you would have managers, supervisors, right? So these relationships could also be within the same table, and you do not want redundant relationships. So that is one thing that with database normalization, that's actually going to be the second thing, is you do not want relationships that are redundant to one another. And they give you an example here, right? If you have these student and course things such as you do before, and you have students have a relationship with teachers, but has relationships with teachers indirectly through classes, then you do not need to have relationships with students and the teachers table. You can just have a relationship between students and classes, and that will, and then from the classes that also has a relationship from the teachers. So you actually need the student teacher relationship. And database normalization. So this is pretty much just rules that are set so that you can create your database to what they would call industry standards. Okay. So first, normal form. So each cell in the table has only one value. So you see right here, let's say you had a product, let's say a bike, and you want what the colors of the bike are. You cannot have uh, multiple colors in one entry or one column, right? The one thing that people would think to do is just have three columns: column one, color one, color two, color three. This is also not industry standard. What you would want is you would want a table for colors. So you'd want the product ID to point to the table of colors, and then for each product ID, of course, you can have a one-to-many relationship with the colors, but you would not want three entries for color in this one table, because these color entries are very similar or the exact same in this case. So I say closely related, but these color entries are the exact same in this case. So you would want a separate table that would have a one-to-many relationship with the colors. Second, normal form. Okay, so all the attributes within the table should be dependent on the primary key. This means, for example, if you would have, well, I give you an example here. If you have age that depends on birth date, you do not need to put age and birth date within the table because they are dependent on each other. You can get age from birth date. So, uh, third normal form. So every non-key column be independent of every other column, which is similar to what I was saying previously with the two colors. being the same, but they give you an example of a multiplicative similarity where you have price and you have tax. And price is dependent, or tax is dependent on price by a certain percentage. So you do not want to keep price and tax stored in the same uh, table, or it's not necessary to even have tax in here because price, and you could always just multiply by a constant to get tax. So there's not a necessity for tax. And there are other forms of normalization that are there. But we can go that other articles will take you through, but these what these articles made sure. Now, what I'm going to do is we're going to actually create an example of a database diagram for Walmart. My initial choice was actually to choose Amazon, but Amazon, just stated about it, is very, very complex with Audible, Prime Video. Everything that Amazon offers is really complex to really try to develop relationships right now in this simple example, given um, in this simple example of what we're trying to do. So what we're going to do is we're just going to instead of, and not eBay either. I thought of eBay second, but eBay also has, you can bid on offers. You don't just exactly have to take the offer. So what we're going to do is we're going to use um, Walmart as an example, online shopping Walmart as an example of how to build a relational database, give the information that Walmart would need to have in its system. So we're going to wait for this to load. And we're going to use a blank template. Okay, that is finished loading. All right, so now let's get started. So let's think now, what does Walmart have, right? The two things it has, of course, will be users and products, right? So let's draw two boxes, one for user, and let's get another box, and we're going to have one for product. So we have users right here. And we have product right here. Okay. And what are some, and now we have users and products. So what we're doing now is we're doing the identifying what we need as far as with the client, which is Walmart, and the customers would need. So, what's some things the users would provide us? Some things would be information, products viewed, purchased, right? All these things are definitely things that you would typically see from observing in a user. So, um, user information, uh, products viewed. What about the spellings wrong? So, products purchase, right? Because you want to know what products are viewed so you can make recommendations. And of course, the user would have their address. And the reason why I put address separate from user information, because users can have multiple addresses. There's two D's in address. Users can have multiple addresses, right? In the same way which we think of credit cards as well, right? Is users can have multiple credit cards as well. So that is done. And what are some things that the products would have? Some things product would have is the product name, perhaps the product description, the price, the quantity, right? So, and this is a tool that I discovered while doing this for while doing the lessons is it's very, very easy to get the structures down that you are trying to get down. So let's see what we need. What we need is the product name, the product description, the price, and the quantity. Okay, so those are some of the things that you need from products, right? The rest, such as whether the user buys, does not buy, those things are going to be given in the table. So now that we have that, let's try to start setting up the information for the users and generating the user table. Okay, so let's use this and start getting the user information down. So we have users, and we already stated previously that we would need different tables for addresses and credit cards because users have many addresses and users have many credit cards. So let's place them here. Oh. So now that we have this, we can now create a table. And that table, the first table we're going to have is users. I just put it in red and bolded so the table names as different as possible. And what are some things we need in the table? So like I said before, the use of primary keys in order to specify information or unique rows are very helpful in database design. So for the user, what we will use is we will use a user ID, which will be our primary key. So this will be different for all users. The user ID, and we have user email, and we have the user password, and we also have, let's say, the prefix, such as Mr., Doctor. For the name, we have the first name, we have the middle name, we have the last name, and we have the suffix for the name. Okay, so that pretty much generalizes a user table. So you have the prefix, first name, middle name, last name, right? So these are things that Walmart would need from its user. And notice that they are all dependent on the user ID. What you can also use is user email, because typically when you sign up to websites like uh, Walmart or Amazon, you keep the same email address, but just having an ID as far as a primary key, structured primary key, let's say of a certain range or format, is also a pretty good way to go as well. And so this was going to be our addresses table, right? Let's change this to addresses. Let's keep this. And what we need for our address, right? So how we know whose address we are looking at currently, right? We need the user ID, but the user ID is going to be a foreign key. They call it a foreign key if it is a primary key in a different table, and it specifies as a key in this table to relate to the other tables. That's how we're going to relate to the table, right? Is using, which users in this address have the same foreign key. And of course, the addresses need IDs as well, right? So we're going to have address ID, and it doesn't have to necessarily be a primary key as far as being unique for every address that's in the address database. It just used to be unique with respect to the user ID, correct? So what we can use as a primary key for this database, though, is we can use the user ID plus address to be a primary key. But we don't really need the user. We don't really need a primary key in. We may or may not need. So it's always good to specify, the user ID plus address ID is going to be our primary key in this example. And now, what are the things that are going to be inside of the address, right? So you have the house number and street name. That's usually in one row. You have the apartment number in a different row, and you have what? City, state, postal code, country. Sometimes I capitalized, sometimes I did not. But of course, when you're actually doing a serious table, you'd want to make sure you have the same format for everything, and you'd want to also know if it's a default address, right? So let's say a user can have a specific default address for one address for a user can be a default address. Okay. And let's say here, this will be our credit cards, right? So credit cards is going to be very, very similar to the addresses. So what we need for credit cards is we need the user ID for foreign key, similar to how we had the user ID for the foreign key for the addresses. And we also need a unique credit card ID with respect to the user, because we don't need it to be unique to the entire data structure. We just need it to be unique with respect to the user, because each user could have multiple credit cards. So, I mean, we could pretty much, for most of this, copy this, and we can paste this, right? So now we have that together, and instead of address, we want credit card ID, right? And instead of address ID, we want credit card ID. And the other fields, right? So you'd have the credit card name that's in the credit card. You'd have the card number. You'd have the card month it will expire. You would have the card year expire. You would have the card CVV code, the code that's on the back of the card that you would need in order to make sure it's not stolen, just an extra couple of digits. And you would also need actually the address ID, right? Because each credit card is matched to an address as far as the billing address. So, the address ID, which the user ID plus address ID will even tell you the address ID is there. So, you could always look up this table, which is why good thing we use the primary key, right? You always use the user ID plus address ID to look up exactly what the address is in the address table. Okay. And so we have the user information, address, credit cards. The product viewed and purchased can only be done once we get the product table underway. So let's do the product tables. We're going to so we have products on this table. All right. And what do we have for products? Okay, so each product is going to be different. So a product ID, as far as a primary key, would be helpful, right? You would also have a product name that would be, for each product would have a name that is dependent on the product ID. So you'd have product name, you'd have a product description, and you would have price, and you would have quantity, and let's say something else you would have is expiration. But if you have expiration, you have price, and you have quantity, that means you're getting multiple shipments. So perhaps it's not better to have price, quantity, expiration, because you will have multiple shipments of the product. So one thing we could do is actually create another table. What I'm going to do is I'm going to use this over here to be the other table, right? Because we don't need this anymore. We'll just brainstorming. So And we are going to call this shipments. And okay, for shipments, what do we have, right? So for each shipment, we would have a product ID, and that product ID is a foreign key, right? So product ID is a foreign key. I'm just going to put FK for foreign key. And you would have a shipment ID, but this shipment ID only needs to be unique with respect to the product ID in this table, correct? Because it doesn't have to be unique to the whole table, just unique with respect to the product ID. And then also, so what the primary key would be in this would be the product ID plus a shipment ID could be a primary key for the shipment. So you have product ID, and you have plus shipment ID, and that equals the primary key. Okay, and for each shipment, you'd have a certain price which you're selling things to, and you would have a quantity of the shipment, and you would have the expiration of the shipment, right? So that makes more sense to have expirations, price, and quantity with respect to the shipment and not the exact product, because the product can change in quantity as it should change in quantity. And the product should change in price as well. And also when the users purchase and they purchase different orders, which you can also see is you can see how the users map to the shipment and the quantities, which we could tell you exactly how much you have as far as in your shipment, given the different relations that you would do. So now that we have the products, the shipments, what do we need? So we need to do the orders, right? So what the users order is important now. So one thing to note is that one user can have multiple orders, and each shipment would be in multiple. Okay, so one thing about orders, which we would just make this in the orders, is as I was saying, users can have multiple orders, and shipments will be a part of multiple orders as well. So what you need is you have a many-to-many relationship with orders and shipments, and you would have a one-to-many relationship with users and orders, because one user can have multiple orders. Multiple orders cannot have one order cannot have multiple users, and also with orders, um, one order can have multiple different products coming from shipments, and a whole bunch of different uh, quantities from different shipments are going to come and be taken from different orders. So this is a many-to-many relationship with orders. This will be order now. And okay. So I have a relationship between um, users and orders and shipments, we're going to now see first we're going to create the orders table. So what would orders have, right? So you need to know the user that's using the order, right? So you would have the user ID. And remember, the user is a foreign key because it draws to one table. But of course, it's not unique to one table because these users can have multiple orders, right? So a good thing to have in order to be able to look it up quicker is an order ID, which does not need to be unique with respect to the whole table, but it needs to be unique with respect to the user ID. And so now what would the primary key be for the order, right? So each order would have a user ID and a unique order ID. So of course, the user ID plus order ID would equal the primary key in this instance. Okay. And what else would an order have? An order would have, of course, it would have the product information, but the products need to be, that's a many-to-many relationship. So we're going to have to specify that when we get there to that stage. But one thing the order does have is it has a shipping address that is the same for everything. Let's just make it simple and say everything's being shipped to one location. So we have a shipping address, and that shipping address is with respect to one of the address IDs, right? So, so we have a shipping address, and that is going to be equal to one of the address IDs that are already there, right? And we also have a credit card. So one credit card is going to make it simple. Say one credit card is going to pay for everything. So we're also going to have a credit card. What did I call it? No, I call it a CCID. So CC ID, right? Remember, we can always draw on this and its uniqueness by just using the user ID plus the credit card ID, or the user ID plus the address ID. And so, that is the purpose of making the table like this, right? So the tables do not overlap information, right? So all you have is an address ID that will relate to exactly what address that the order needs to go to. You have a credit card ID that can tell exactly what credit card the order has came from, and the user ID and the order ID and the user ID enables all of this. So that is an example of the uniqueness. So now let's do the many-to-many relationship of orders and shipments. Remember, what happens with many-to-many relationships? You need something. I'm just going to use this because we don't need this anymore. That was just brainstorming. Okay, let's give this some space. I didn't mean to do that. And so this is going to be the table that is in the middle of the orders and the shipments to make the many-to-many relationship. And we're going to call this orders to shipments. Okay. So what would this table need? Right. So of course it would need the order ID, and well, it would need the primary key from the orders, and it would need the primary key from the shipments, and then it would need a quantity, right? So how much is it? How much does it need from uh, this, right? So it would need, how much is it taken from the shipment, right? So we can always backtrack and see, exactly how much merchandise is being taken, or if we have how much we need before we need to get another order, before we have to stop taking orders, right? So, the primary key for this order would be the user ID and the order ID. So user we have user ID and we have order ID, and that'll make the primary key for the orders. And we have shipments, right? We need the primary key for these shipments, exactly, what product and what shipment is being given to what order. So we have product ID and we have shipment ID. And we need to know exactly what quantity, right? So we can, in the end, tally up exactly, how much is left. So we need quantity here as well. And so that should complete the table. So now these shipments, all these shipments, let's say if I have 500 here, I can always just search. I can relate to this table trying to find the exact primary key that I'm using for the shipment that I have. And I can see exactly, I can see each time this key is brought up, and I can, add up the quantities and see exactly how much I have left as far as shipment, right? So this is our many-to-many relationship. And so now what we can do is we can draw lines to the tables. This is not needed. I'm going to delete this. And so now we have the users table, right? Let's try to widen the gaps between some of these. Okay. And we have orders. Oh, let me delete that. Okay. Order right here. We have, no, not mean to do that. We have addresses right here. We have credit cards. So we have users. Like I said before, we're going to make the lines here. So we have users going to addresses. Remember, this is a one-to-many relationship. No. Okay. So we're going to use 2 for one-to-many relationship. And we have users to credit cards as well, which is a one-to-many relationship. So copy this and paste that. Okay, there we go. It pasted. So now we have our it's going to credit cards. And this one, I think it's this one as well, is going to credit cards. These two need to match up. But of course, you don't want lines to go through. I'm trying to move the line so it does not intersect. Okay, so I didn't want the line to go directly through the credit card, but seems to have a mind of its own at this point. So it will pass through the credit card. So these user credit card is a one-to-many. And also remember, the credit card also needs the address ID. But the address ID, one credit card can only have one address. Right? Yeah, a credit card can only have one address, but many addresses can be mapped to a credit card. Correct? So this will be one too many as well. So this is actually the copy and paste what I did before. One too many. One, and this would be too many. Okay. So user ID is set, and we have products to shipments. So one product will have multiple shipments, correct? And what else? We have orders, right? So one user would have multiple orders. So one user, order, user, order. Now just move this, combine it. So we have a one-to-many relationship where we have the orders can have many products, and the products can be a part of many orders, of course. So this would be a one-to-many. And move this here. And this would be a one-to-many. Wait, I don't want that to be overlapping. I want the tails to be overlapping. Okay. So, it's a pretty good example of how you would do a table. Of course, it's simplistic. Walmart has many more things that are probably put in here, like views that they're using. well, whatever data they're capturing, right? They'll just capture it if they need to break up to create another table. This is pretty much a way to make a relational database or structured table. You have the many relationships that are recorded, as you can see here, the one-to-many, the one-to-one. There's actually no one-to-ones, but for one-to-ones, what I was going to say is, remember what I said about having the prefix and the first name, middle name, last name? Sometimes these things are not in there. So what you can have is, probably one-to-one relationships with, actually prefix. Most of the time there's a first name and last name. So probably one-to-one relationship with prefix, middle name, and suffix would probably be best. So, just separate tables with, user ID and prefix, another table with middle name and user ID, another table with suffix and user ID. So the user ID would tell you exactly how it relates to the user table. So yeah, that would be the one-on-one relationship that's there. But time is up for now, and I will stop sharing. And if there are any questions, I will be here for the next 5 minutes. All right. I'll check Slack to see if there's questions posted on Slack. one thing that the order can have as well is it can have the date. So instead of an order ID, you just have the date, right? The date and time should suffice as far as an ID, because it'll be very hard to try to order something twice in the same time span. Although feasible, but most times when you do use time as far as a unique key, you do it up to you know uh, milliseconds at the very least. So it'll be difficult. I guess it's not impossible. So I guess just do a primary key then. It's not impossible. Maybe really difficult to pull off using two computers, or just trying to get that going somehow. But I mean, it'll be hard work for anybody, and they'll have to just use a regular key, I guess. Well, that is the 5 minutes. My time is up. Thank you for watching this, and that is it for this week. All right. Good luck on the projects. Peace.